revision topics 1, 2, 3. Topic number 1, states of matter. In states of matter, you must know the difference in the comparison between solid, liquid, and gas. In solid, particles are close together in regular arrangement. In liquid, particles are still closer but irregular, gas far apart. So the first point that we have a difference between solid, liquid, and gas. In states of matter, the difference between solid, liquid, and gas. In solid, particles are close together. Liquid is still closer. Gas far apart. In solid, particles close but regular arrangement. In liquid, irregular. Gas also irregular. For solid, have fixed shape and volume. Gas is the opposite. It changed or indefinite shape and volume. So you'll find that solid and gas are opposite. Liquid in between, fixed volume, but it changed or are definite shape. Takes the shape of the container and takes the takes the shape of the container, but the gas takes the shape and volume of the container. For solid, you'll find that particles vibrate around its position. In liquid, slide over each other. Moves randomly in all directions. So for solid, liquid, and gas, you must know that solid have fixed shape and volume, particles are close together in regular arrangement, vibrate around its position. And also for compression, you'll find that gas can be compressed because particles are far apart. In liquid, difficult to be compressed, cannot be compressed. And also for diffusion, you will find that diffusion takes place in a liquid but is slow. In a gas, fast. And solid cannot. So this is a comparison between solid, liquid, and gas. Solid, particles are close together, regular arrangement, have fixed shape and fixed volume, vibrate around its position, cannot be compressed, cannot be diffused. Liquid, particles is still closer but irregular, have fixed volume and take the shape of the container, so change shape, and particles sliding over each other, can be compressed but difficult, have diffusion but a slow rate of diffusion. Gas, particles far apart, have a changed shape and volume, takes the shape of the container and the volume of the container, and you'll find that it moves randomly in all directions, can be compressed because particles are far apart, and also you'll find that have diffusion with faster rate of diffusion. So particles close together regular, still closer but irregular, far apart. This is number one. Number two, For conversions from one state to another, solid can change into liquid, and liquid can change into gas. Solid can change into liquid melting, liquid to gas evaporation, gas to liquid condensation, liquid to solid freezing. And you will find that solid can change into liquid directly, and solid can change into gas directly, or gas can change into solid directly without passing with liquid. For solid to be like gas is called sublimation. So for solid to gas directly is called sublimation, and gas to solid deposition. From solid to liquid and liquid to gas by heating. So it is endothermic process. What's meant by endothermic? Heat is taken, heat is given, heat is required to make the reaction. And you'll find that particles, when making heating from solid to liquid or liquid to gas, particles moves faster, and particles gets farther, for particles to move from solid to liquid and liquid to gas. So solid, liquid, liquid to gas. So solid to be liquid, particles still closer, and then to be farther. And the size of particles stays the same. So the particle size doesn't change, but the change in the distance between particles. So its size must be the same, but only the distance between particles only changes. While in case of it changing from gas to liquid and liquid to solid by cooling, and you'll find that particles will be slower and closer, but the size of particles is the same. For the heating curve, you will find that it changed from solid to liquid and from liquid to gas. If we have A moves to B and B moves to C, C to D, D to E, and E to F. So from solid, liquid, and gas. From A to B, this is solid. C to D, this is liquid. E to F, this is a gas. From E to C, this is melting. D to E, evaporation. And you can know the purity of the material from melting and boiling point. In case of pure materials or pure substance, you will find that it contains fixed or sharp melting and boiling points. If we have impure materials, melting point will be lower and boiling point will be higher. If we have impurity, melting point will be lower and the boiling point will be higher. Like for example, if we have melting and boiling point for water, you will find 0 and 100. In case of impure, maybe -2 and 102. So the impurity lowering melting point and higher the boiling point. This is number one. So in the first stage that we have states of matter and conversions from one state to another. After that, heating curve, and then kinetic theory. by increasing temperature particles gain kinetic energy. So particles moves faster. Then particles have more collisions, more successful collision per unit time. So it have faster rate of reaction. After that, diffusion. What is meant by diffusion? Particles spread out from a region of high concentration to low concentration. So what's meant by diffusion is spreading out the molecules from a region of high concentration to low concentration. And it takes place in liquid and gas. In diffusion, you'll find it takes place through liquid and gas. Here's this solid, liquid, and gas, and there's a convergence, heating curve, solid to liquid, liquid to gas, melting and evaporation. This is a cooling curve, is opposite directions. After that, diffusion. Diffusion takes place in a liquid and a gas. And liquid, it will be slow, and in gas will be fast. What's meant by diffusion is spreading out of the molecules from a region of high concentration into low concentration. For example, if we have beakers that contains water, and then you are dropping drops of ink, you will find that the color of the water be colored by the color of ink. This means that the ink have high concentration and the water have low concentration. Also, if we have iodine as a vapor and we have two jars, one of them contains iodine vapor and the other one is empty, and then you have a slide. When you remove the slide, you will find that it moves randomly in all directions to fill the two jars. This means that diffusion takes place. So diffusion takes place in a liquid and a gas. In a liquid, to be slow. In a gas, to be fast. And also, diffusion depends on MR, the molecular mass. Lower MR will diffuse faster. The lower MR will diffuse faster. In case of, and rate of diffusion increase by increasing temperature. In case of the experiment between hydrogen chloride and NH3, NH3 and HCl. The MR of NH3 from the periodic table, N equal 14 plus H equal 1 multiplied by 3 to be equal 17 grams. The MR of HCl equal 1 plus 35.5 equal 36.5 gram. So NH3 has lower MR, so it diffuses faster. So you'll find that NH3 react with HCl to form NH4Cl. NH4Cl is formed near to HCl. Explain why NH4 is formed near to HCl. Because NH3 has lower MR, so it diffuses faster. So this faster rate of diffusion, while HCl is slower rate. After that, solubility. In any solution, you will find that solution consists of solid and solvent. What is the difference between solid and solvent? In any solution, it consists of solid and solvent. Solid plus solvent forming solution. Solid is a solid that will be dissolved in a solvent. Solvent, liquid that the solid dissolve inside. For example, if we have salt and we have water, they are mixing together to form salt solution. After that, in dissolving, there is a standard saturated solutions. What is meant by saturated solutions? In saturated solutions, you will find that the materials can dissolve until there is no more solid can dissolve in solvents. It's called saturated solution. So what's meant by saturated solutions? No more solid can dissolve in a solvent under this temperature. So, for example, if you have a cup of tea or cup of water, and then you're adding a spoon of sugar, the first spoon dissolve, second spoon dissolve, third dissolve, fourth doesn't dissolve. So, till the third is called saturated solution. So, what's meant by saturated solution? That there is the maximum solubility. No more solid can dissolve in solvent at that temperature. Solubility increasing by temperature. By increasing temperature, solubility increases. And by lowering temperature, solubility decreases. So this is the solubility. By increasing temperature, you will find that solubility increases. Number 2. The difference between element, compound, and mixture. Element, one type of atoms. What is meant by one type of atoms? This means that it consists of similar atoms. Like, for example, if we have S8, 8 atoms, but all of them are sulfur. P4, O3, diamond, graphite. So element, one type of atoms or similar atoms. While compound and mixture, they consist of different atoms. Both consist of different atoms. But in case of compound, consists of different atoms but with fixed ratios. And also you'll find that cannot be separated physically. Can be separated chemically only. Form new materials or new substance with different properties. For example, if you have carbon dioxide, ammonia, sodium chloride, water, or any compound like that have fixed ratios. What's meant by fixed ratios? For example, if we have carbon dioxide refers to one carbon and two oxygen. If we have one carbon and one oxygen, there is another compound. It will be carbon monoxide. If we have CO3, it will be carbonate. So it have fixed ratios. Cannot be separated physically. For example, carbon dioxide by adding water and stirring, it will not form carbon and oxygen to be separate. So cannot be separated physically. Form different new materials with different properties from its elements. For example, sodium chloride. Sodium reacts with chlorine to form sodium chloride. Sodium is a metal. Chlorine is a gas reacting together to form a solid of sodium chloride, table salt. This is different from sodium alone and chlorine alone. While in case of a mixture, you'll find that different atoms, but is any ratio can be separated physically. And you'll find that in a mixture, like for example, if we have air is a mixture, and also crude oil or petrol is a mixture, seawater or salt solution mixture, alloys, mixture of metals. So the mixtures consist of different atoms, but with any ratio. And also we'll find that in a mixture can be returning back, but while and can be separated by physical methods, while in a compound cannot be separated by physical methods. After that, the difference between atom, ion, and isotopes. For the structure of atom consists of two main parts, nucleus and electrons. Nucleus that consists of protons, which is positive, neutrons, which is neutral, there is no charge, electrons, which is negative. For the mass, protons mass 1, neutrons 1, electrons 1 over 1840, and sometimes round to be 1 over 2000. So the mass of electron can be neglected or cancelled if it compared to the mass of nucleus. So the atom consists of nucleus and surrounded by electrons. Nucleus that contains protons and neutrons and revolves around them electrons. And the atom is electrically neutral. Why atom is neutral? Number of positive charge protons equal number of negative charge electrons. So positive equal to negative, protons equal to electron. For that reason, atom is neutral. So in the structure of atom, consists of nucleus and revolves around them electrons. Nucleus that contains the protons and neutrons, protons which is positive, neutrons which is neutral, electrons which is negative. Mass of protons 1, neutrons 1, electrons 1 over 18, 37, sometimes to be 40 or 2000. So the mass of electron can be neglected or cancelled if it's compared to the mass of nucleus. And the atom is neutral because the number of positive charge protons equal number of negative charge electrons. After that, there is ion. What's the difference between atom and the ion? In atom, you will find that atom is neutral, proton equal to electrons. In case of ion, what's meant by ion is a charged atom. Atom after losing or gaining electrons. So atom is a charged atom. And proton not equal to electrons because in ion lose or gain electron. So it will form positive or negative ion. Positive ion refers to losing electrons. So it will form positive ion. While in case of negative ion refers to gaining electrons to be negative ion. For example, if we have Na1123 and Cl1737 or 35, and then the number of protons equal 11, number of electrons equal 11, protons equal 17, electron equal 17. So the number of protons equal number of electrons. Number of protons equal number of electrons. This in case of atom. An ion is a charged atom, so must have positive or negative, like Na positive or Cl negative. This is called ion. So in ion, you must have a charge, positive or negative. So protons equal 11. Electron equal losing 1 electron, 10. This positive means lose electron. So proton is greater than electron. While in case of negative ion, proton equal 17, electron equal gaining electron, 18. So electron is greater than proton. So the difference between atom and ion, in atom you will find that proton equal electron and there is no charge. In ion, proton not equal to electron may be positive ion or negative ion. Positive ion refers to losing 1 electron, and then proton is greater than electron. While in case of negative ion, electron is greater than proton, and you'll find that negative charge. While in a positive ion, positive charge, in atoms there is no charge. If we have any element like Na1123, this number is called atomic number and number of protons. number of electrons. So atomic number 11, number of protons 11, electrons 11, 23. This is a mass number 23, or nucleon number due to nucleus also 23, or sum of protons and neutrons 23. So 23 is a mass number, nucleon number, sum of protons and neutrons. 11 atomic number, or number of protons or number of electrons. The difference between mass number and atomic number is the number of neutrons. Number of neutrons is the difference between mass number minus atomic number. So it is equal to 23 minus 11 to be 12. What is the difference between Na and Na positive in the number of electrons only? If we have Na positive, 1123, the number of electrons equal 10. So the difference in the number of electrons only. So difference between atom and ion in the number of electrons only. So we must know that the difference between atom and ion in the number of electrons only. After that, there is isotopes. What is meant by isotopes? Atoms of the same element, and we must say same element, with same number of protons, different number of neutrons. So atoms of the same element with same number of protons, different number of neutrons, or same atomic number and different mass number. Like, for example, if you have carbon C 612, 613, 614. Number of protons for each one, protons equals 6 for all. Electrons also equal 6. Neutrons is the difference, 6, 7, 8. So this means that in isotopes you will find that we have protons equal protons, electrons equal electrons, but neutrons not equal to neutrons. So the difference between atom, ion, and isotopes: atom, proton equal electron, and there is no charge. Ion is a charged atom. Proton is equal to electron, may be positive or negative ion. Positive ion refers to losing electrons. Proton is greater than electron. Negative ion, electron is greater than proton. While in case of isotopes, protons equal protons, electrons equal electrons, but neutrons not equal to neutrons. And in this case, we must know that in isotopes, explain why. They are same element, and explain why they have similar chemical properties. Why they are same element and why they have similar chemical properties. They are same element because they have same number of protons. They have similar chemical properties because they have same number of electrons in the outer shell. So atoms of the same element with same number of protons, different number of neutrons, or same atomic number and different mass number. Why they are same element? Because they have same number of protons. Why they have similar chemical properties? Because they have same number of electrons in the outer shell. And relative atomic mass is the average atomic masses compared to carbon-12. Relative atomic mass is the average atomic masses compared to carbon-12. For example, if you have Cl17, 35 and Cl17, 37, calculate relative atomic mass. Relative atomic mass is equal to 35 plus 37 over 2 to be equal to 36. This in case of equal abundance. If we have different abundance, like for example, if you have Cl1735, Cl1737, and the abundance of Cl35 70%, and the abundance of 37 30%. In this case, relative atomic mass is equal to mass number multiply its abundance plus other mass number multiply its abundance over total abundance. So it means that 35 multiplied by 70 plus 37 multiplied by 30 over total abundance 100. So in case of Cl1735, Cl1737 without abundance, this means that they are equal, so 35 plus 37 over 2. But in case of different abundance, so mass number multiply its abundance plus other mass number multiply its abundance over total abundance. In separation of mixtures, separation methods, in separation methods, we have number one, filtration, and we have distillation, and this distillation can be classified into sample and fractional, and we have chromatography. Filtration, it depends on soluble and insoluble materials. The soluble one is called filtrate, and the insoluble is called residual. While in case of distillation, it depends on different boiling points. In case of chromatography, it depends on different colors or different solubility. Number one, filtration. In filtration, you'll find that we have filter funnel, filter paper, beaker, this funnel, filter paper, filtrate and residue. This down is filtrate and this residue, the solid remains. So filtration depends on soluble and insoluble materials. How we'll make filtration? Adding water, stirring, and then filter. So number one, if we have a mixture, to add water and stir, then filter. After making filtration, we have filtrate and residue. To obtain crystal of each one, for filtrate, we'll make crystallization. And residue, we'll make wash with distilled water, then dry. Again, in case of filtration, we have filtrate, the soluble one, and residue, the insoluble one. So filtrate is the soluble. Residue is the insoluble. How to obtain crystals? For example, if we have salt and water, salt by adding water, stirring, and filter. For example, if you have mixture of sand and salt, how can we make separation for sand and salt to obtain crystals of each one? Number one, adding water, stir, and filter. This is a mixture. Add water, stir, then filter. After we make filtration, sand will be as a residue, salt will be as a filtrate. So this is the soluble one like the salt. This is the insoluble one, this is sand. After that, how we make crystals? For sand, wash with distilled water, then dry. How to obtain the salt from salt solution? Crystallization. Heat, cool, filter, dry. Heat the solution till crystallization point. Allow to cool, then filter, and then dry. You will find that in crystallization, this filtration. So after that, we'll make crystallization. Crystallization, heat, cool, filter, dry. Heating the solution till crystallization point. How can we know that crystallization point had been reached? By mixing with glass rod, crystals formed. So this is a glass rod, dipping the glass rod until crystals formed. So crystallization, heat, cool, filter, and then dry. Heat the solution till crystallization point. So how can we know that crystallization point had been reached? Dipping glass rod, crystals formed. Allow to cool, then filter, and then dry. The drying between two filter papers or in a warm place. This is crystallization. So if we have a mixture of salt and sand, by adding water, stirring, then filter, you will find that we have residue and filtrate. The residue, like sand, wash and dry. The filtrate, like the salt solution, by make crystallization, heat, cool, filter, dry. Heat the solution till crystallization point, allow to cool, then filter, and then dry. How can we know that crystallization point had been reached? Dipping glass rod crystals formed. This is number one, filtration. Number two, we have distillation. In distillation, we have simple and fractional distillation. So what is the difference between simple and fractional distillation? Both depends on different boiling point, and both simple and fractional distillation is started by evaporation, then condensation. Okay, for simple distillation, it can be used to separate soluble salt in a liquid. Like, for example, if we have seawater, consists of salt and water, so it can be using simple distillation. But fraction distillation, if we have miscible liquids, what's meant by miscible? In case of solid, we have soluble and insoluble. In case of liquid, we have miscible like soluble and immiscible. We can't say for liquids that they are soluble together, but they are mixing together. This means that they are miscible. So fraction distillation can be used if we have miscible liquids. Like, for example, if we have petrol or crude oil or liquid air. Air is a gas, but it be compressed to be liquid. Or aqueous ethanol. So miscible liquids mixing together. And in drawing, you'll find that in the apparatus, the difference between simple distillation and fraction distillation, that they have fractionating column. This is a simple distillation, round bottom flask, and condenser to cool and condense the vapor. You must see that this is water in, and here is water out. This is a condenser. What's the purpose of condenser? To cool and condense the vapor, to collect here as droplets. If we haven't condenser, it will be evolves. So we have a condenser to cool and condense the vapor. So this is a round bottom flask, condenser to cool and condense the vapor. After that, is a beaker to collect the water. In fraction distillation, you will find that we have fractionating column. What's the purpose of fractionating column? Fractionating column, it have glass plates to take more time for the liquid to can be separated easily. So if we have more than two liquids, they are near to each other in the boiling point. Like, for example, if we have alcohol 78 and water is 100, they are near together in the boiling point, so must passing through fractionating column to have timing to separate each component alone. And also in crude oil, if we have gasoline, kerosene, diesel, and we have different materials, they are close to each other in boiling point, can be separated by fractional distillation. So the difference in drawing between simple and fractional distillation only in fractionating column, but both contains condenser, flask, beaker, and thermometer. What's the purpose of thermometer? To measure the temperature of vapor. We can't say to measure the temperature of liquid. No, it can measure the temperature of vapor for the gas, not for the liquid. So thermometer to measure the temperature of the vapor, and condenser to cool and condense the vapor. And also we have sample and fraction distillation. In sample distillation, if we have soluble, solid, and liquid, while in case of fraction distillation, if we have multiple liquids are mixing together and be close to each other in the boiling point. After that, chromatography. In paper of chromatography, you will find that if we have materials that we have different colors or different subtlety, like for example, if we have protein or green leaves or amino acids. So if we have any material contains more one substance, and then we need to make analysis, it depends on different bonding, different colors or different subtleties. At the beginning, we have paper of chromatography. So here, this distillation, simple and fraction distillation. After that, the third one, chromatograph paper. In chromatograph paper, you'll find that we have the paper, and then we must drawing with pencil or graphite. It is a baseline or origin and must be drawn with pencil or graphite. It is called baseline or origin. Must be drawn in a pencil. Why must be drawn in a pencil? Not to dissolve. So it's drawn in a pencil, not to dissolve. Pencil or graphite. This is number one. Number two, in case of chromatograph paper, we have any material like amino acids, proteins, so must dissolve the material to be in a liquid. So if we have solid materials or solid substance, at the beginning must to be dissolved. Dissolving, if we have amino acids or if we have proteins or green leaves, dissolving in organic solvents can be dissolved in water like alcohol. After that, and if we have large surface, so crash at the beginning with mortar and pestle and then dissolve. After that, after dissolving, filter. So now we have filtrate. So at the beginning, if we have solid substance in large pieces, crashing with mortar and pestle, then dissolve, and then dissolving in organic solvent and filter. Take filtrate. Put drops of filtrates on baseline or origin line, and then wait, immerse the chromatograph paper in a solvent, while the baseline must be above. So level of water or solvent is below the origin, lower than origin. Why must be lower than the origin? To prevent spots from dissolving, to prevent dissolving of spots. After that, wait until it reaches end. Count the number of spots, will form number of spots equal number of colors. Again, this chromatograph paper. In chromatograph paper, we will take drops of the filtrate, putting in origin, and then immerse the chromatograph paper in a solvent while the baseline must be above. Then wait until it reaches end. Count number of spots. Number of spots equal number of colors. These are the spots. This is the chromatograph paper. This solvent the front. And sometimes you are adding locating agent. What's meant by locating agent? Locating agent is be added in case of colorless solutions. If we have colorless materials, so we must add locating agent to see the spots more clear. So in case of adding colorless solution, we must add locating agent. So locating agent is added in case of colorless solution to see the spots more clear. After that, how we can determine the position of the spots? By two methods. Measuring the spots formed. Number one, by comparing with other known materials. Number two, by using RF values. Comparing other known materials, for example, this is the spots format. Here is red color. Here is orange, blue. So by comparing the distance with other known materials, so we have now the colors that we have, comparing other known materials. RF values, what's meant by RF values? Equal distance traveled by solid over distance traveled by solvent. Distance traveled by solid over distance traveled by solvent. Like, for example, if we have this is a spot forward. The distance from baseline to the spot considered to be x, and distance from baseline to solvent front y. So RF value equal x over y. So this is traveled by solid from the baseline to the spot, and the distance traveled by solvent from baseline to solvent front. So by solid from baseline to spot, traveled by solvent from baseline to solvent front. This is how to measuring RF values. Distance traveled by solid over distance traveled by solid, so by solvent. This traveled by solid from the baseline to the spot over from the distance from baseline or origin to the solvent front. After that, in case of element, compound, and mixture, there is also molecule. What is meant by molecule? More than one atom. Although they are similar or different. So in a molecule, it means that more than one atom. They are, if be similar, to be element. If they are different, so they are compound. So we can say a molecule more than one atom. They are made to be similar, to be element, or to be different as a compound. Also, in case of, how can you know the material is solid, liquid, or a gas from room temperature? If we have melting and boiling point lower than room temperature, 25 degrees Celsius, so this is a gas. If we have melting point and boiling point is greater than 25, this is solid. If the room temperature in between, so the melting point is lower than 25 and the boiling point is greater than 25, this is a liquid. For example, if we have -50 and -5, so this is a gas, both numbers as lower than 25. If we have melting and boiling is greater than 25, like 100 and 500, so this is a solid. If the two numbers in between, like 0 and 100, like water, so this is a liquid. So two numbers is lower than room temperature, a gas. The two numbers is greater than room temperature, this is solid. The number in between, so this is a liquid.